Good morning. So welcome you to attend this course MA4832 on microprocessor system. So this session is about the course briefing. So I will give you an overview about this course before we start lecture 1. So my name is Xie Ming. I'm the course coordinator, and you can find the detail of my educational background and the research interest from this web link. And this slide also give you my educational background, my research focus, and also my contact detail. So you can email me or call me at this handphone number. This course is about the microprocessor system. So look at the title. So you have a keyword system. System means it's something which can take input, which can produce output, and which can undertake internal processing in order to produce output from the input. Then here is a definition of a microprocessor system. So basically, inside the system, we can undertake arithmetic operation, logic operation, and also to have an interface with external device. So interface could be at the input side, for example, interface with the sensor so that we can get the sensory data from the sensor, or interface with the actuator so that we can output commands and take action. Okay, so this is a definition of a microprocessor system. So you are going to learn how to use this microprocessor system for the design of a system at a larger scale, because in future you may be engaged with the design of a smart product or smart system in which microprocessor system is one of the module inside the smart product or inside the smart system. Okay, so you are going to learn this very important system or module. And why do you need to incorporate microprocessor system into your product or into your system at a larger scale? And basically, there are two reasons. One is you may develop application which involve the control and the automation. Then in this case, inside your application, there must be a closed loop control system. And inside the closed loop control system, you see there must be a module called as a controller. Okay, so this is one scenario of application or motivation for you to study this course. If let's say in future, you may be in charge of developing application with control and automation. Okay. Second motivation behind the study of this course is in future you may be in charge of product or system which focus on data communication, like this scenario. So then in this case, you must know how to set up a network, how to exchange data between two devices. Okay, so these are the two typical scenario of application in which you must incorporate microprocessor system. Okay, so that gives you a motivation for you to study this course. And here is an example for the control. So you will see this motor is
这是带霍尔的五刷电机驱动器。
So then we have a micro
从运行状态来看，还算平稳。
processor. Okay.
后期再继续优化。
And here's another example. each robot will be under the control of a brand, okay, microprocessor. And the third example.
Now I'm going to show you some demonstration.
So I quickly run through it. So you will see inside the body of this robot may be many microprocessors. For example, to control the finger of the robotic hand, we may use microcontrollers to do
I am
feedback
certain
control.
object. Now I get object's position. Now I move my arm to approach object. I move my arm to touch target. I close my hand. I move my arm to ready position.
Okay, so this is a typical scenario. Okay, application in which we must incorporate the use of a microprocessor system. Okay, and here's another example. Okay, so you see for such application, the presence of a microprocessor system is necessary. Then this is an example we show you the deployment of a robot in production line. Because the video is quite long, and I just quickly go through it.
The Adept 1 and Adept 3 robots utilize pattern robots. In this presentation, we plan to show you that robot guidance vision is now practical and can benefit your robot installation.
For truly flexible, efficient manufacturing, what should you look for in a robot guidance vision system? There are three major requirements. First, robot guidance vision must not slow the robot. Rapid data processing is important to maintain cycle times and throughput. Also, the system must handle randomly oriented touching and overlapping parts, because that is how parts are generally found in factories. Finally, it must be easily implemented so your engineering time and costs are minimized. For the first requirement, speed, two Adept Vision features give you rapid processing. The vision electronics in all the Adept systems are housed in the same controller that drives the Adept robots. This way, the vision system and the robot system communicate through the multibus backplane. Most other systems don't communicate to the robot through a backplane and therefore require a separate vision controller. Because of Adept's integrated controller, communication is much faster. Also, Adept Vision has its own dedicated Motorola 68000 microprocessor, so that vision data and robot data are processed in parallel. That means the robot continues its cycle while vision data is being processed. And when the robot reaches its destination, it can respond immediately to the vision information. Adept Vision's integrated communications and parallel processing provide timely information while maintaining rapid cycle times. The second requirement for robot guidance vision is the need to handle randomly oriented, touching, and overlapping parts. Adept's feature-based recognition technique makes this possible. By feature-based, we mean that it locates the right combination of corners, straight line edges, and arc edges of a part, which it can find at any angle of rotation, even if parts touch or overlap. Because as long as enough features are located, the system extrapolates the rest of the image and identifies the parts. This means you can present parts loosely and at any orientation in simple trays or on conveyors. Finally, robot guidance vision must be easy to install and train. Since Adept Vision is integrated into the Adept controller, implementation is simplified because you eliminate the need to design cables and connections for communication between a vision system and a robot with two separate controllers. Write software to communicate between the robot and vision system. Adept robots and vision systems already talk the same Val2 language. And you eliminate the need to write a calibration program to reconcile the coordinates of the vision and robot systems. Training is simple too. Adept Vision systems are designed specifically for robot guidance.
Okay, so we move on.
Once these are sighted, assembly function cell has also performed to the cell.
So basically, you see in the production line, there are a lot of smart machines.
To manipulators are innovation caused by the
rotated task frame architectures to scale to complex systems and more general tasks. These examples illustrate one way in which a control basis can enhance robustness with respect to geometry and manipulator kinematics. Preliminary results suggest that this control structure dramatically improves the combinatorics of planning and...
Okay. So from the previous video, at least you see the need for data communication between two modules. Okay. So therefore, the microprocessor system plays very important role in the design of a smart machine or smart system in industry and in society. Okay. Then come to the learning objective of this course. Why should you study microprocessor system? As I mentioned in the previous slide, the basic motivation is if you are going to work as a designer of a smart system, smart product in future, in which there must be the presence of a microprocessor system, then in this case, so you must study this course, okay? And the second motivation is in future, you may make use of a smart product or smart system developed by others. Then in this case, you must know, okay, how such system or such product works, okay? So therefore, the learning objective is described by this slide. Roughly 70% is for you to become a designer of a system with a microcontroller inside, and 30% is for you to become a user of a system with a microcontroller inside. Okay. And what are you going to study in this course? This course is structured into two parts. The first part is about the software, how to operate the microprocessor system. And the second part is about the hardware, so which will allow you to know how to interface microcontroller with external device. Okay, so interface has a two part. One is to interface microprocessor system with input device, for example, sensor, keypad or keyboard, or speech or vision, etc. And the second requirement is how to interface with the actuator, such as motor or switch, etc. Okay, so you will see. So this course is divided into two parts. Okay, so on top is about the software part. Okay, and below, so you have you must study the way to interface with the input device and also the way for you to interface with the output device. Okay, so this slide basically show you the roadmap of learning for this course. Okay. Then besides the lecture, this course also involve hands-on practice. Okay, and the teaching material basically come from the textbook plus the reference book. Okay, so inside the NTU Learn, we have upload some reading material for you, and you can go to library to read the extra material if you want. So I believe, okay, the material that we have placed inside the NTU Learn are sufficient enough for you to fully understand the content of this course. Okay. Then for the assessment, so you will see the CA will consist of 40% of the final result, and the exam will consist of 60% of the final result. The exam is open book. It will last for 2.5 hours. Okay, and the question will come from part one. Part one will be taught by me, and the part two will be taught by Professor John Han. And you will see half of the mark will come from part one, and half of the mark will come from part two. Okay, and in terms of CA, so CA could be in the form of a quiz or assignment or combination of both. Okay, so we will make an announcement to you about the specific way of doing continuous assessment. All right, so this slide basically show you the component of assessment in terms of CA and the final exam. And this slide is just for you to know, okay? So there are 6 basic ways of learning, and you will see, okay, reading textbook, listening to lecture or tutorial, and doing practice or project, okay, are very important. Then you present your result, the outcome of your learning, and eventually you can write your report and apply whatever you have learned to do a mini project or to demonstrate something, small application, okay, something like that. So these are the 6 pillars, okay, underneath the learning by student, okay. And the good news for this course is you have opportunity to read, you have opportunity to listen, you also have opportunity to do practice and the project with this course, okay. So let's quick overview about this course. And thank you for your attention. Then we are going to move on to study lecture 1.